right, today we're going to continue our work with lesson 18, how fractions are division. And we're starting with page 379. And with these kinds of pages that say try it, it's a good idea if you were to try it on your own. That's what we'd normally do in class. And then we would stop and we would share our different ideas and different strategies. So if you would like to do that, I would think that's a great idea. And then you can always then come back, do the problem, try it, and then come back and take a look at how I solved and see how it's the same, how it's different. If you need to make any changes, you can then do that. Here is the question. We have Jared, Monica, and Heather, so these three people, have 5 hallways to decorate for the student council. If they share the work equally, how much will each student decorate? So we are dividing up, and as we're dividing up, we have 5 hallways, and it's being divided among the 3 people. So even though the 3 people are listed first, that is not my dividend. My dividend is my 5. I have 5 halls. That's what's being divided. 5 hallways, and it's being divided among 3 people. So I'm not going to divide up my people. I'm not putting that first. And remember that fractions is division, so 5 divided by 3 can also be written just like that. It also can be written like 5 divided by 3. All different ways to write division. So if I think about this, I have more halls than people. So then, therefore, my answer is going to be more than 1. I'm going to do a picture for this. So I'm going to start with my 5 halls. Here's our 5 hallways. Okay, I'm going to divide it among my 3 people. Okay. So they're each having to do a third of each one of those walls. Okay, I can put my A, B, and C in there. Person A, person B, person C, and keep doing that. I could color code it and make it really obvious who is doing what part of the wall. But as you can see, I'm going to end up with 5 groups of a third per person. And if I have 5 groups of a third, I have 5 thirds. Ta-da! Of the hall. Now, 5 thirds is over a whole, and it looks kind of weird to leave it like an improper fraction. It's technically correct, but to write it as an improper fraction isn't what we normally see. So I know 5 thirds is really a whole, which I can put these 3 thirds together. There's a whole. 3 thirds is a whole. And then I have 2 thirds left over. So I can say 3 thirds here is equal to 1, and then I have another 2 thirds over here. Okay. So I know that's the same as 1 and 2 thirds of the hall. Okay. So there's our first question. I could do a division problem too if I wanted to. So say I wanted to divide my 5. I think this is how I would normally do it, or what I'm kind of doing in my head here. I have my 5, and I'm dividing it into 3 parts. Well, 3 fits in once, so I know they're going to have 1 whole. And I have 2 left over out of 3. Just like when we would write our leftovers, our remainders as a fraction, that's the same thing here. So that's just kind of the quicker just computation way to get your answer too. So notice 5 thirds is the same as 5 divided by 3. If I have 5 of something and then divide it into 3 parts, I'm going to get 5 thirds. Okay, it says explore different ways to understand it here as we just are kind of looking through here. This first one was fraction bars, which is really what I did. They just color coded it and they put their initials for each one. As we're seeing from there, you can still see that each person ends up getting a third of each of those wholes, which ends up being 5 thirds. You can also do a number model. Here they're showing the 5 hallways, and And the first picture here, they're showing how they are getting 1/3 of each of those wholes, and they end up with 5/3. So then down here, they made kind of a new number line where it's rearranged to show that they're each getting 5/3 or 1 2/3. They put all their parts together. Okay, we're going to go ahead and pass the next page. And we're going to go to apply it. For number 8, it says 5 friends are sharing 3 packs of football cards. How many packs of cards will each friend get? And use a visual model to support. So even though these are really friendly small numbers, our strategy here is to really practice in 5th grade how we can practice that fraction is division through visual models. So one thing we want to make sure we do is we want to make sure we have in mind which is our dividend and which is our divisor. So you want to think to yourself, what is being sharing? Is the 5 friends being shared or the packs of football cards? Well, the football cards are. So you're not going to go straight across just because that's what the question looks like. 5 comes first, then 3. Well, that doesn't matter. Here we have the friends are not being divided up. Their 3 cards or 3 packs are being divided. And they're being divided among 5 people. Okay, and so 3 divided by 5, should start to kind of see this relationship, is the same as 3/5. So they should each get 3/5 of a pack. Now it does say that we want to have a visual model of that. Okay, so for a visual model, we can start with 3 packs. And we're going to divide our packs among 5 friends. So they're each going to get 1/5 of each one of these packs. Okay, and again, you can then label A, B, C, D, E on each one of them. You could color code them 5 different colors, but we do want to kind of show that each person is getting 1/5 times 3. Getting 1/5 of 3, which is the same as 3/5. 3 groups of 1/5. And there's our visual model. So I'm going to just do shade kind of just in different colors. So there's one person. Here's the next person. Here's the next one. I need 2 more colors. Let's see. See what we got. That may be a yellow. And I'll do black. There we go. So there's our visual model. We could do division too. If you looked at division, I just want to show you that that works, even though it says a visual model here. I just want to show you that this is a good way to check yourself. 3 is being divided by 5. And again, I know that looks weird, but if you think about it like money, I can write 3 wholes that way too. So then if I wanted to do this as a division problem, I can do my box method just like I always do. It's kind of my chosen method there. And as I work through, I can think to myself, how many 5s fit into 3? Ooh, that got really messy there. How many 5s fit into 3, which would be 0, because they're not getting a whole. Okay, I gotta work on my writing here with my pen. I bring up my 3, because 3 ones the same as 30/10, and that is 6. 5 fits into 36 times, which is 30. I have nothing left over, and I can bring up the 0, which is going to be 0 again. So I get 0.60 hundredths. I can say 60 hundredths, 0 and 60 hundredths. I can say 0 and 6/10, which is exactly the same as 3/5. If you got 3 out of 5 right on a quiz, you would get 60%. All right, next one, Elena, which is my daughter's name, just spelled different. Elena made 10 ounces of apple chips, She put the same amount of apple chips into each of 4 containers. How many ounces of apple chips are in one container? Write a division expression to represent the problem and solve. Write the solution in remainder form and as a mixed number. Use a visual model to support. So we're going to go back and look at what we have here. Well, we have 10 ounces, and the ounces are being divided into 4 parts. So we've got our 10 ounces. We're really thinking about what's being divided up. That's what's being divided, the apple chips, into 4 containers. And that's where we don't know our answer. But we know that 10 divided by 4 can be written this way too, which is our answer. We can say that each container is 10/4 ounces. Just looks a little weird. That's why it's telling us to write that as a mixed number. So if I have 10/4, you have to think about how many wholes and how many are left over. So we're going to jump to our visual model. For our visual model, I'm going to start with my 4 containers. So my 10 ounces is being divided among my 4 containers. So if I divide up my 10 into 4 parts, I can think with my ounces, if I gave them each, maybe 2, you're each going to get 2, right? They're each getting 2 ounces. Kind of start there. It's kind of one way to look at it. Okay, so right now I'm at 8, right? And they need another 1/2 of an ounce each. Because I had 2 ounces left and I still had like 4 bags. So they're each going to get 2.5 of their ounces. So that would be kind of one way to look at that. So in that particular picture, I have 4 parts and I'm dividing, and I want that 10 to be divided equally. So I'm getting 2.5 in each of my containers. So my answer can be 2.5. Okay. And I also can look at this and say that 10/4 is the same as 2.5. 10 divided by 4, think about it like that, fits in 2 times, and I have 2 left over, and it's said to write your leftover as a fraction. So that would be 2 left over out of 4, which is the same as 2.5. So I can say 2 2/4, I can say 2.5, or I can say 10/4. They all resemble the same thing. For this question, you could do a number line too if you wanted to. You could go to 0 to 10 and figure out how you can divide that into 4 equal parts. I think this picture probably is a little bit easier to do that with. So 10 divided by 4, they're going to have more than a whole in each. Does the remainder form or the mixed number form best answer the question? You wouldn't want to say they would have 2 remainder 2 ounces in each. You don't want to leave out the ounces. You want to use all of the ounces. So that leftover 2 here, you want to use as a fraction. So it says this question right here, does the remainder form or the mixed number form best answer the question? It would be the mixed number form. We want to use all of those ounces. We don't want to put 2 in each container and then just leave the 2 left over. Those 2 left over can be divided up by putting a 1/2 in each. So answer that question. And then the final question on this page is, which expression is equivalent to 12 divided by 7? Well, that's 12/7, and we just talked about fraction is division. So there it is. The numerator divided by the denominator can be written like that, can be written like this, and it can be written like a fraction. Ta-da! All those are the same thing. Okay, so if you had 12 pies and you divided them among 7 people, they would have more than 1. They would have 1 and 5/12 that was divided up equally. Here's an example problem they have on the next page. It says there are 4 packages of printer paper to be divided among 6 classrooms. There are 4 packages for 6 classrooms to share, which is 4 wholes divided by 6. If you divide each package into 6, each classroom would get 1/6 of each package. So 1/6 of each package from 4 packages is the same as 4/6. So there's the good picture of 4 groups of a sixth making 4/6. Okay, it says circle the number line you would use to solve the problem. So you want to look closely at 4 divided by 6. So look at the choices here. Which one has 4, and then the 4 is being then divided into 6 parts? And that would be the first one. The first one has 4, and if you look between each whole, it's being divided into 6 parts. So each person could then get a 6th, or each classroom, I should say, a 6th of those parts. Number 2, look at the example. Suppose only 5 classrooms share 4 packages. How would the model in the example change? And how would the answer change? So if there was only 5 classrooms, it wouldn't be 4 divided by 6. It would be 4 divided by 5. That looks like a plus, sorry. Let me erase that. Be 4 divided by 5. So if you have less classrooms, our answer will change a little bit. So instead of 4 dividing by 6, I have 4, and I'm dividing that among 5. So remember that equals 4 divided by 5, which is the fraction 4/5. So instead of an answer of 4/6, it becomes an answer of 4/5. So the model would change because each whole would be divided into 5 parts, not 6. So that's what you'd want to write that here. How would the model in the example change? Each whole, each package would be divided into 5 parts, not 6. And then how the answer would change? The answer is now 4/5 instead of 4/6. So make sure you answer that. Okay, if you move on to number 3, Trish is taking care of the Han family dogs. The Hans leave 7 cans of food. For 3 days, they will be away. How much food will the dogs get each day if Trish feeds them an equal amount each day? Show your work, write the answer in remainder form and as a mixed number. So this case, it's not telling us we have to then write it or draw it, but we certainly could. We have 7 cans, and this is where you want to make sure, you want to make sure you really think about what is being divided up. In this case, it's the cans. So we have 7 cans, and they're being divided among 3 days. Okay, so 7 divided by 3 can look like this. 7 divided by 3. It can also look like the fraction 7 divided by 3, which is 7/3. It does say to write the answer in remainder form and as a mixed number. So in this case, we can write it either way. We can do it as the remainder forms, which I'm going to do that next. I'm going to say, here's my division problem. 3 fits into 7 2 times, so I know they'll get at least 2 cans. Then I get 1 can left over. So I can write that as 2 with a remainder of 1. I also can do that same problem, but instead of writing it as a remainder, I'm going to write it as a mixed number. So in this case, I would say 3 fits into 7 2 times. Again, subtract and I get 1 left over. But this time, I'm going to write the leftover, that 1 left over out of 3. And that really makes more sense for this particular question because I want to use all the cans. I don't want to have leftover cans. So that makes more sense to me. So Trish is taking care of the Han family dogs. They leave 7 cans for 3 days. How much food will each dog get if Trish feeds them an equal amount each day? Well, they're going to have 2 1/3. Write the answer in remainder form and as a mixed number. So 2 1/3. And I could draw a picture of this if I wanted to too. So I would start with 7 cans. This would be another way I could draw a picture. So here's my 7 cans. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I could say day 1 gets 2. Day 2 gets 2. Day 3 gets 2. And then I got to divide this last one up between day 1, day 2, and day 3. So they're each getting 2 whole cans plus 1/3 of another can. And then we kind of talked about that already underneath it. Which best answers the question, the remainder form or the mixed number? Well, definitely the mixed number, because there's no need to keep an extra can. We can divide that up very easily. So they could get a little bit more each day. So instead of just using 2 cans and saying, we got an extra can, we don't know what to do with it, we can go ahead and say they get 2 1/3 cans per day. So definitely the mixed number makes more sense. So if you have something that can be divided up equally, do it. Cookies, cans, things like that, money. But not everything can be divided. Sometimes you just have something left over. Number 4 says Raul, and make sure, by the way, you write the answer for right here. Okay, why is a mixed number a better answer? Okay, number 4. Raul plans to run 30 miles this week. He wants to run the same number of miles each day of the week. He says he will run 7/30 mile each day. Is he correct? So let's look at this again. We have 30 miles, and he wants to do it the same amount each day. Okay. So what's being divided up? Well, the 30 is. The 30 miles is being divided up among the 7 days of the week, and that should look like a division problem. Nice. There we go. Try that again. There we go, much better. Okay, so the 30 miles is being divided among the 7 days. Okay, so remember that's the same as or equal to 30 over 7, which is not that. Definitely more than 1 mile a day. So definitely 7/30 does not fit that. So they flipped it. That person made a mistake and divided 7, the number of days, by the number of miles, which would be incorrect. So you want to explain and just say that Raul did the 7 divided by 30 instead of 30 divided by 7. So the answer would be much higher than that. If you wanted to divide that up, 30 divided by 7 fits 4 times. We have 2 out of 7 left. So it would be 4 2/7 miles per day. So his answer really isn't reasonable either, because that's not 7/30 isn't even a whole or even close to a whole. So when it says explain, make sure you don't just say no because the answer is 4 2/7. Say something like Raul, divided 7 divided by 30 instead of the miles divided by their days. So the answer should be much more, 4 2/7 miles. And the last one here. Gus makes 48 fluid ounces of spiced cider. If he serves an equal amount to each of 7 people, will each person get more than a cup of cider or less than a cup? And it does remind you here that a cup is equal to 8 fluid ounces. So that's just kind of a little reminder there for you. Let me circle that nicely. There we go. All right, so we have 8 fluid ounces, and it's being divided among 7 people. And they want to see if they end up with 8 fluid ounces. So I have my 48, which is my ounces. That's my dividend, number being divided up. It's being divided among 7 people. I like to write that out because then I'm really making sure it makes sense. I don't want to divide my people into parts, right? That doesn't make any sense. Equals blank. So I have my 48. I'm dividing it by 7. It fits in 6 times, which is 42. And I get 6 left out of 7. Since I'm dividing up ounces, I can definitely write that as a mixed number. I don't want to put remainder 6. I want to say that there's 6/7 ounces left. Now, so that's me solving. Now I have to answer the question. Will each person get more than a cup or less than a cup? Well, if a cup is 8 fluid ounces, that is not a cup. They will not get a cup each. And here is my work here. I did a division problem right here. I interpreted my remainder by making it a fraction, so I have a mixed number answer. So 6 6/7 ounces is what each person's going to get. So they will not get a cup each. I could draw a picture of this too. It didn't say I had to on this particular one, and I thought that I could kind of divide that pretty equally or pretty easily through just a division problem. Okay, so hopefully that makes sense for today. I just really want you to understand that whole idea of looking at a story problem, making sense of it, really thinking about what's the dividend, what's the divisor, and knowing that you can write fractions as division problems. And even this last question, I could rightly write 48 over 7. That is technically correct for my answer in ounces. It just doesn't make a lot of sense like that as an improper fraction, but that's equal to 6 6/7. But technically, I could say each person is getting 48/7 because 48 divided by 7 can be written this way. But then when it goes to ask you, is that more or less than a cup? Well, you got to figure out what that equals. And that equals 6 wholes and 6/7. We will do more of this in class. Hopefully it makes sense. You should have nice, clear work for me and have a wonderful day. Thank you very much.